Hey everybody, so it's about 7:40 right now, and well, for me, for you guys, it is in the afternoon tomorrow, and I will be having fun at the NC State Fair, and you're stuck in school. So anyway, we're going to go ahead and get started with this lecture, and I'm sorry for the room. I know it's echoey. Let's just get through it. I didn't have time to try and find another spot besides the room to do the lecture in. So, you probably already see me in geometry today, doing a lecture for that, but we're going to go ahead and get started about using plants wisely. The first thing we're going to talk about is asexual propagation. So Heidi, I know you've done this before. Some of you others might have done this before, but essentially we're going to propagate a plant without using seeds, because seeds are a form of sexual reproduction. You have the pollen fertilizing the eggs or the ovules. That's sexual reproduction. Asexual propagation is when you are creating a clone of a plant. It happens in nature. There's something called vegetative propagation, and that's another word for asexual reproduction. A clone is an organism that is genetically identical to a parent plant, and you can do this one way through underground storage structures. If you think about planting potatoes, potatoes are parts of the roots that store a lot of energy for the plant. That's why they're so nutritious. They have a lot of parenchyma cells, and they are considered a tuber. But there's some other types of underground storage structures like bulbs, so you can think of an onion or a tulip, and then corms, such as a crocus plant. Stolons are specialized stem structures that form new plants and take root some distance from the parent plant, and you can think of strawberries or peanuts, or even, I'm blanking on the name, Costa Bermuda grass. They'll send out essentially a root, and that root will repopulate that same plant, and the new plant that pops up from it will be connected to the old plant, and it will be a clone of the old plant. Other plants that produce new plantlets that drop off from specialized stems or leaves take root right beside the parent plant. Some trees will reproduce from the roots, and in fact, the largest organism is one of these, and I think it's an elm grove in Washington State. Some plants reproduce clones through leaves planted in soil, such as violets or aloe vera, or a bunch of different succulents. Sexual reproduction can create a problem for people trying to make a uniform product, and that's why asexual reproduction is more valued. So if you think we want a potato and we want the highest quality potato there ever was, so we can make McDonald's French fries, and we're going to want an extreme amount of genetic uniformity to make the best potato, because if it has any genetic variation, then the ones that are the variants are not going to be the perfect potato because they're slightly off. So we're going to make clones of everything, and that's what a lot of agriculture is just making clones of stuff so we can have a certain quality about it. You might think that's bad, and in some practical ways it is. So say you have a certain range of genetic variation. You always have, but it's extremely small. And then there's a disease that comes through. Well, that disease is probably going to wipe out your entire crop if it's bad enough, because there's no genetic variation, so none of those individuals have a gene that could defend against that disease. But it's probably what you prefer. So when you go to the grocery store, you don't want to get weird looking potatoes. You just don't. You're not. If you did, you wouldn't buy them. And so it's kind of this thing where what do you want? Do you want to sacrifice perception over genetic diversity, and maybe less sustainability, or do you want to sacrifice sustainability for not eating weird food? So it's kind of a cultural thing. In how this plays out, in anything that has a tree, we're going to graft something on. So that's how we make a clone. There is a famous graft in terms of pecan history. It was called Antoine's graft. He was a slave, and he was the first person to ever make a commercially viable pecan tree. All pecan trees before Antoine, and he did not have a last name. We actually don't know really anything about him besides he never profited from his invention. But all the pecan trees before him had an extreme amount of genetic variability, which in this context it meant they did not, you never know what the quality would be when you went out to pick pecans. So there were wild groves of pecans everywhere along the Mississippi River. Well, Antoine was able to get a really good stem and a tree that had really, really good roots. So he took his stem, he cut it off of the first tree, and he made an incision in the tree that had really good roots. And he tied the stem into that incision, or that hole in the tree with the good roots, and he cut all the other stems off of that tree. That's what's called grafting. And then once that happened, that tree now only produced the high quality pecans of that one stem. And then once that tree got big enough, people were able to go to it, cut stems off that original stem, and start grafting their own pecan trees. Doesn't really matter what rootstock you have, as long as you have a good root system, it would produce the same types of pecans. And that's how we got commercially viable pecans, is through grafting like that. And all commercial trees are pretty much all are grafts, whether it be figs, apples, I'm blanking, plums, anything that's grown on a tree, that's going to be grafted on. So it's a form of asexual reproduction, a way that we can ensure quality in growing our plants. Another way of cloning a tree is through layering. So you take a stem, you bend it down, you make an incision around it, not really a hole, but this time a scratch, a really big scratch. You put some root hormone on there, and then you cover it up with dirt. And you've now planted that stem. It's still connected to the tree, but you've planted it. Eventually that stem will grow roots, and after it's grown enough roots, you can cut it off from the tree, dig it up, and plant it wherever you want to, and you have an entirely new tree grown from one stem. It's a clone as well. So some of the plants people use would not be able to survive without human intervention, and a famous example is the banana. So if I'm not mistaken, wild bananas are extinct. We don't have them anymore, but we're able to artificially propagate bananas over and over and over again. They're a really big crop, and because they're all performed artificially, we wouldn't, if humans stopped taking care of banana orchards, they would just cease to exist. We would not have any more bananas, sadly. Something that happened really big in all of our lives, not during our lives, but for our lives, is called the Green Revolution. And the Green Revolution was an event in the early 1900s where we took all of the ideas that we had been learning about chemistry and agriculture and started applying them en masse. So we had a bunch of good ideas, but they weren't necessarily being performed all at once. We took all those ideas, performed them all at once, and we were able to create more food than we ever have in the history of the world combined. So it's really cool. People don't like it though, and we'll get into that in a bit. So essentially, in the early 1900s, late 1800s, we had been creating things like chemical fertilizers through the Haber-Bosch process. We had been creating chemical pesticides like DDT. We had been creating crops that were more productive and less prone to insects than ever before in the history of mankind. So we started putting all that together, and we got incredible yields. Now, of course, the problem with that is we're using a lot of chemicals in our society. So we started getting a lot of pollution really fast. And during the 70s, the green movement came about, and we had to regulate a lot of our chemical usage in agriculture. But it was able to save millions of lives. We started exporting these ideas to foreign countries, and in certain places, obviously not everywhere, but in certain places where people were dying of starvation, we were able to come in, give them new seeds, give them chemical fertilizers and pesticides, and they were able to flip that into actually being able to survive. Now, of course, the kickback comes from environmental concerns. So one is fertilizer runoff. When you apply a water-soluble fertilizer and you apply too much of it, it is going to get wasted. When it rains, it's going to get into the rainwater, and then it's going to go down, down, down into a burning ring of fire. Into the aquifer. And when it goes into the aquifer, that's hit water supply for humans and other animals. So it causes algal bloom, it causes chemical tainting of the water that we drink. So it's really bad. Like, this is stuff that can cause cancer. And that was especially bad, say, in the 70s, before the Green Movement took off. The Green Movement is good and bad. So there's some people who don't think it did enough, and that we have to do way more. But if you look at pictures from the 70s, say, of the Neuse River in North Carolina, there was a lot of erosion, and that was through other bad farming practices that we've curtailed, specifically tilling too much, and that does a lot of bad stuff to the soil. But because we're able to implement processes like no-till agriculture, we've curtailed how much fertilizer we apply, and we've understood more about how to apply fertilizer in such a way that it does not get wasted. We're able to do a lot more for the environment than we were before the Green Movement. So it's overall, it's been good, at least during its initial run in the 70s. Erosion was another thing that we kind of just talked about. The Dust Bowl happened, so we had tilled so much farmland that there was no topsoil. We hadn't been rotating crops. That was another thing that we added into the mix, is crop rotation. So you don't grow the same crop over and over again, because you'll drain your soil of nutrients and organic matter and soil structure. We took out the structure of the soil in the Midwest, and the wind came and just kicked it up, and it was really bad. People got dirt pneumonia. So essentially, there was so much dirt in the air from the wind blowing it all around that their lungs were literally caked with soil, and they died. Not everyone, but a lot of people. So erosion we've been able to solve pretty much through the Green Revolution. So the Green Revolution, I think, is undeniably overall a good thing because it saved millions of lives. There's also bits of colonialism that people like to throw in there from a sociological point of view, and you have to take their word with a grain of salt. You guys will watch a video on that later on in the class. So another thing that we're going to talk about with using plants wisely is drugs. I'm going to talk about drugs today, kids. So, as an anecdote, there's something called the common foxglove, and it's extremely poisonous. If you eat it, you will die. But we can take that common foxglove. There's a certain chemical in it that we can extract, and it's actually an important heart medicine that can be prescribed in extremely small doses. And only professionals are able to prescribe it. We also have something called opium poppies. I believe it is the largest export of Afghanistan, probably the only export of Afghanistan. So it's a powerful painkiller, and it has been a extremely popular drug for centuries, maybe even millennia, and it's native to the Middle East and to the area. It might even be native to China, because China used to export a lot of it. And it's brought relief to many patients suffering from pain as a result of accidents or surgery. It is where we get morphine from, which is an alkaloid similar to caffeine. Drugs from it are called opiates, but it's also done a lot of bad stuff. So during the American Civil War, people would take morphine in order to get rid of the pain. Very disturbing war, and you didn't really need, but they helped a lot with the pain that veterans were experiencing. So a lot of people wanted to give it to the veterans, but the problem was as it got more exposure, people got more addicted to it. And over time, people were able to create even more potent chemicals from the opium poppies, one being heroin. It was created as a non-addictive opiate alternative, but it's actually far more addictive than opium ever was. There was a guy named Jack Fishman who developed naloxone after World War II to serve as a drug to counteract opium addictions. There was also coca. If I'm not mistaken, coca was brought to the United States by the Department of Agriculture. During the McKinley administration in the late 1890s, they would send out, it was during the era of imperialism where America tried to go around the world and kind of shove its weight around, or at least the first time it tried to do that. There was this guy named Daniel Fairchild, and he had a sponsor named Babur Lathrop. So essentially, he was an employee of the U.S. Department of Agriculture as a food explorer. So he went around the world trying out different foods and trying to see if he could get seeds or some type of propagative material to bring back to the United States and plant. So he's the guy you can thank for having avocados. So if you like guacamole, he's the guy who shipped the first commercially viable avocado seeds to New Mexico, where they where orchards were started. But he traveled in South America, in the Andes Mountains, and there was this leaf that people would chew on in order to get energy to climb the mountains. And so his sponsor, Babur Lathrop, would use it. And I believe it was he, not Fairchild, who brought it back to the United States. And it was called coca. Now, similar to opium, opium poppies, it had an alkaloid in it that was the active ingredient for the leaf. People there just use it kind of like we use coffee. Now, this opiate, if concentrated, is extremely addictive. It's called cocaine. And people in the late 1800s started to use it. In fact, during Prohibition actually was before the amendment. So in places like Atlanta, they had outlawed alcohol before it was outlawed federally. So there was this guy named John Pemberton. He was a Civil War veteran, not to be confused with the other John Pemberton who defended Vicksburg during the Mississippi campaign. But anyway, so he could not sell alcohol at his drugstore. So he started selling drinks with cocaine in them. And it also had another drug from the cola plant. And so because he had additives of both the coca plant and the cola plant, both of which are now illegal. He called the mixture Coca-Cola. And of course, they've changed the recipe since, but the original Coca-Cola recipe had coca or cocaine in it. And Coca-Cola to this day is the only company inside the United States allowed to import coca. Now, they don't put the cocaine in it. Somehow, through some chemical process, they take out the cocaine, but if you, the argument goes that's the reason why it has a unique flavor compared to other colas, is because they actually use the flavors of the coca plant without using the cocaine. Now, of course, it's marketed by cartels illegally with associated violence and addiction, so it's been used not wisely. And that's it. So essentially, the point of using plants wisely is we need to think about how we're using them in things like opium poppies. Are we using them only for bad reasons, or are we using them, say, for painkillers? Because there's two very big differences. If you're using them, if you're using something, say, like Tylenol, which isn't from opium, but just as an example, versus the heroin, very different. If you're going to increase yields in food production, you also need to make sure to manage the environmental concerns as well. So with that, go ahead and complete your coursework, and that is going to be reading pages 294 to 297 and performing section review 15C, and I'll see you tomorrow.